Hello and welcome to another video of Digital Electronic Circuits Lab. Today I will be reviewing this power meter. This is a DC power meter and I have been using this for my solar power project for quite some time. But now I have some doubt regarding the efficiency and the accuracy of this power meter. This one is the model number PZEM031 and the voltage range is DC 6.5 volt to 100 volt and current range is between 0 to 20 amps, and it is a generic branded Peace Fair branded power meter. So first I will test the accuracy of this power meter with my bench power supply and DC load. I will be using a H4 headlight bulb for using as a load, and after that, after testing, I will just remove the back cover to see if there is any adjustment knob provided inside, because from outside you cannot adjust anything if there is a error. So let us take a look at the efficiency and the accuracy of this power meter. So here I am ready with some connecting wires and load and my bench power supply. So I will just connect the wires to the input terminal first. So the inner two connections are for input. So we'll connect the red wire to positive, and the black wire to negative. So before connecting the load to the power meter, I will test the no load power consumption of this meter, because it comes with a backlit. So by only using the backlit and LCD, how much power it consumes, let us first measure that. So I will connect it to my bench power supply using the connecting wires. And I will set the power to 5 amps and 12 volt. So as you can see, I have set the bench power supply to 12 volts and 5 amps. Now I will connect it and I will turn it on. So this is this way around. So as you can see, it is showing 12 volts at the moment and 11.9799 volt. It is actually fluctuating a little bit, but it is more or less accurate, and my bench power supply is also showing 11 volt at the moment. Now I will connect the load to the power meter and see how much efficient it is. At this point it is consuming 1 milliamps of current, so that's fine because it is using the LED backlit to show the LCD. So now I will connect the load to the power meter and then I will check how much efficient it is. So here I have already connected the load to the power meter, and now I will power it on. So at this point it is showing 11.21 volt and 19 watts of power. Now this headlight bulb is rated at 35 watts, but now at this point of time it is consuming only 21.22 watts. So I don't know why there is a power drop. I will just go ahead and increase the voltage a little bit, and as I can see from here itself, there is a significant voltage drop. It is now showing 11.46 volts at the point, and my power supply, bench power supply, is at 11.999 volts. So I will just go ahead and increase the voltage little bit. So now I have changed it to 14 volts, and now it is consuming 26.4 watts and consuming 1.8 amps of current. But the power meter is showing 13.37 volt, and it is showing 25.1 watts and 1.88 amps of current. So it is showing the current more or less accurate, but the voltage, it is not showing accurate. There is a significant difference of around 0.5 volt at this point, around 0.55 volts less it is showing. And the power also, since there is a difference in voltage, there is a change in power also. It is actually consuming 26.47 watts of power, and according to the power meter it is 25.2 watts of power. So there is a significant change in the power. So now I will just go ahead and open the back of this power meter to see if it is possible to change any settings inside using some potentiometer to adjust the voltage, because there is a error in the voltage measurement. So if it is possible, so let us check that. So for that I will remove the wires, connecting wires from this. So to open this, there are some small clips on both sides of the power meter. So I will push it, and hopefully by pushing it will come out. So this is the inside look of this power meter, and there are some small screws on four corners. So we'll try to remove that also, see if it comes out. So here is the power meter from inside, and I guess this one is the current measurement shunt resistance for the current measurement. And yeah, it is connected between these two terminals. So I guess this one is the shunt resistance for measuring current. Now the current measurement is more or less accurate, but the problem is with the voltage measurement. But from inside I cannot see any potentiometer to adjust the power meter to rectify the error. So there are some discrete components here, some resistor, some capacitor, one crystal oscillator, a electrolytic capacitor, and probably this one is the main chip to control the power meter. It is HDL Tech HT16281B. So probably this one is the main control chip, and here one more chip is there, but the markings are not visible properly, so it is not readable. And this one is 2N60, and probably it is a MOSFET, I guess, to switch the power supply for this circuit. And here is one comparator, I guess, 8 pin comparator. And on the front side there is only one LCD and a button to reset the power meter. So this is the inside view of this power meter, and my conclusion of this power meter is that there should be one potentiometer to adjust for the error measurements, because as it is measuring a significant power error, so there should be some provision for adjustment, and that is not provided. Apart from that, the current measurement is more or less accurate, and the power meter build quality is pretty good. Circuit and all that, it is well soldered. So that's it guys for this video. Please subscribe to my channel for more videos like this, and if you have any suggestion, please make sure to comment in the comment section, and if you like the video, please hit the like button. So thank you very much for watching. Have a nice day.